Welcome back to water quality in the Pacific Northwest. We're starting a new chapter today. We're going to be talking about drinking water for the next 5 units. We take a look at the components in this chapter on drinking water. We're going to be talking about the Safe Drinking Water Act, sources of drinking water in the Pacific Northwest, public perceptions of drinking water in the Pacific Northwest. We'll talk about the major drinking water contaminants. And finally, we'll end up talking about some rudimentary drinking water treatment that can be used within the home. So we're in lecture 28, and today we're going to be talking about the Safe Drinking Water Act and sources of drinking water in the Pacific Northwest. And at the same time, we'll be talking about the two major sources of drinking water: public water systems that most of us are on, and private water systems. If we take a look at the history of drinking water in the United States, before 1974, the United States Public Health Service, abbreviated USPHS, regulated drinking water in the United States. More specifically, the Surgeon General had responsibility for drinking water quality at the federal level. Most of us think of the Surgeon General today, and we think of when we were kids watching TV ads where the Surgeon General is talking about the dangers of cigarette smoking. Well, prior to 1974, when people thought about the Surgeon General, they were thinking about their drinking water quality. The first standards for drinking water were issued in 1914 by the U.S. Public Health Service, and they revised these standards in 1925, again in 1942, 1946, and in 1962. So there is a history of drinking water action at the federal level, but it wasn't a major effort. By 1962, based on the U.S. Public Health Service, we had standards for physical parameters in drinking water, chemical parameters, and microbiological parameters. So we had a set of standards that were basically enforced. But what we didn't have is we didn't have any standards for any organic contaminants in drinking water. Radionuclides in drinking water was another area where we just didn't really have many standards. So drinking water was kind of neglected at the federal level. All 50 states took their guidance for drinking water quality from the U.S. Public Health Service until the Safe Drinking Water Act was passed. In the late 1960s and early 1970s, there was a lot of advocacy for environmental programs in this country. It started with the Clean Air Act, followed by the Clean Water Act, and in 1974, Congress passed what we know as the Safe Drinking Water Act of 1974. It's abbreviated as SDWA. The Environmental Protection Agency, which was a newly formed agency at that time, the EPA got its birth in the late 1960s, and when it became an agency, Congress gave it to the authority to enforce to enforce the Clean Water Act and the Clean Air Act. We move ahead to 1974 when the Safe Drinking Water Act was passed. Congress basically said this is something that the Environmental Protection Agency should also regulate. So the authority for the law comes from Congress, but the EPA is the tool to carry out what Congress passed. The Safe Drinking Water Act is the only statute that we have on the books in the United States that is intended to ensure that the quality of water at the tap in your home. It's what protects our water supply for human consumption. The Safe Drinking Water Act, again, was passed in 1974, and it celebrated many anniversaries. Here's a logo of when it celebrated its 40th anniversary in 84, 94, 04, 14, in 2014. So the Safe Drinking Water Act is basically 45 years old right now. The Safe Drinking Water Act did some very important things. It set up government oversight of both surface and groundwater sources of drinking water. It set up programs for the development of standards and regulations, and we'll talk a little bit about that later on. It set up a system that funded state and local water systems. Unlike today, back in the 1970s, when Congress passed a bill, the money flowed with the bill to the states. They weren't unfunded mandates like oftentimes we see today. Within this act, monitoring programs were required. Local community water systems were required to monitor water at all times to ensure that it was safe for human consumption. And basically, when this act was set up, so the Safe Drinking Water Act of 1974 authorizes several things that I think that are important in this discussion. First of all, the EPA is required to conduct basic research on drinking water. Basically, when somebody finds a contaminant in drinking water that isn't regulated, the EPA is responsible to do research to see if this contaminant is harmful to the human health. If it is, the EPA will regulate it. If the found contaminant does not impact human health, they will ignore it and they will move on to the next potential contaminant. This act also authorizes the Environmental Protection Agency to provide technical assistance to states as they request it and to municipalities as they request it. In addition, the EPA has money to provide money to states so they can be helped in managing their drinking water programs. Now, if we look at what needs to be regulated based on the the Safe Drinking Water Act of 1974, the classes and chemicals and contaminants that were authorized to be regulated included: 1, microbial contaminants, bacteria, viruses, parasites like protozoa. Now, these have basically been regulated by the U.S. Public Health Service, and communities recognize that certain microbial contaminants definitely had an impact on human health. So we've been chlorinating water supplies in the United States since the late 1890s. So naturally, this would fall under the Safe Drinking Water Act to be regulated. And we didn't know much about viruses in 1974. We still don't know much about viruses today. But we knew that there were certain bacterial pathogens. We knew that there were certain protozoa pathogens. We knew that algae was maybe a problem, but we didn't know what specific algae caused the problems. So Congress authorized EPA to work on microbial contaminants and regulate them. Congress also, in the Safe Drinking Water Act, said that the EPA needs to evaluate and regulate the class of contaminants that we call inorganic chemicals. That includes things like heavy metals and other inorganics. Heavy metals like lead, copper, mercury, and aluminum, for example, here. And other inorganic contaminants such as sulfates, nitrates, nitrites, a whole gamut of inorganic chemicals. That was a class of categories that needed to be regulated. So we had the microbials and we had the inorganic contaminants. Thirdly, the Safe Drinking Water Act of 1974 said that we needed to start regulating organic compounds. Up until the Safe Drinking Water Act was passed, there had been no regulation for organic chemicals. And we use hundreds and hundreds and hundreds of different organic chemicals in the United States. A lot of our manufacturing processes, a lot of the chemicals we use improve our lives. But the question is, at high concentrations, are these chemicals harmful to human health? So EPA was directed to look at a class of organic chemicals that are called volatile organic compounds, abbreviated as VOCs. And VOCs are basically carbon-containing compounds that will vaporize easily from water into the air. Another class of organic chemicals that the EPA wanted to be regulated were synthetic organic compounds, abbreviated as SOCs. This is a large class of carbon-containing chemicals. They are chemicals that humans manufacture, humans discovered, manufacture, and they're widely used. So up until 1974, our organic compounds had been ignored. The Safe Drinking Water Act changed this. Another class of chemicals, the fourth class of chemicals that EPA said that needed to be regulated, were radionuclides. And radionuclides can be naturally occurring isotopes of some radioactive chemicals we have heard of, such as uranium, radon, and radium. Natural occurring chemicals that at high concentrations may adversely affect human health. So Congress directed EPA to look at these chemicals as potential hazards in drinking water. Before I summarize, there is a fifth class of chemicals that we'll talk about a little bit later. So we have the microbials, the inorganic chemicals, the organic chemicals, the radionuclides. The fifth class is turbidity, or the clarity of water, and we'll actually talk about turbidity a little bit later in the next lecture or two. So if we take a look at the summary of the Safe Drinking Water Act of 1974 and just ask a couple questions, who and what? Well, first of all, the Safe Drinking Water Act of 1974 regulates drinking water produced by public water supply systems, which we'll define in just a few moments. The 1974 law provided authority to monitor and regulate 22 different water contaminants. And if we analyze how was this act perceived, what did it do, and if it was successful, most analysts will say that the Safe Drinking Water Act of 1974 had a huge positive impact on public health and safety. As a matter of fact, poll after poll after poll has shown that the American public overwhelmingly supports the Safe Drinking Water Act. But this act in 1974 was the first look at drinking water, and it only addressed the major contaminants that basically we already knew about or that we had an idea that would cause trouble. The 74 Act lacked provisions for adequate enforcement of some of the regulations, and it also did not address contaminants that people suspected were problems in drinking water but had not been addressed yet. As a result, Congress was pretty active with the Safe Drinking Water Act, and the Safe Drinking Water Act received two major amendments and two major reauthorizations over the years. It was amended and reauthorized in the period 1984 to 1986, and again in 1996. And this is a long, these laws are very detailed. I just want to give you an idea of what they did. If we take a look at the 1986/1984 amendment, because it was a 2-year period over which it occurred, the amendment reauthorization changed the number of chemicals that were actually regulated. Remember, this 1974 Act authorized 22 chemicals or 22 components to be regulated. They added another 83 water contaminants. The 86 Amendment significantly expanded the protection of drinking water. And this amendment required EPA to develop primary drinking water standards. And we'll talk about standards a little bit later. So there were actually about 20 different provisions that were in the 1986 Amendment. These are just some highlights. Again, if we go to 1996, Again, the Clean Water Act was significantly amended and reauthorized. And when we say reauthorized, uh, the reauthorizations received overwhelming support in Congress. The 1996 amendment added significantly more water contaminants to this list. So we were up to about 200 different chemicals. The 96 amendment actually contained 19 major provisions. And these provisions are fairly familiar to us today. So this was a very far-reaching amendment. One of the things that I think that was really important about the 1996 reauthorization is that it strived to create partnerships with communities, and it solicited public input about contaminants. Up until 1996, it was the EPA and the scientific community using scientific data that set standards. The public was basically shut out of the process. Well, the 1996 amendment said the process had to be transparent and public input had to be solicited and listened to. Okay, so we have the Safe Drinking Water Act of 1974, and it significantly improved the safety of drinking water to many Americans. Now, there are basically two major sources of drinking water in the United States that we need to talk about. We have public water systems and we have private water systems. There is a big difference between these two types of systems. Public water systems are regulated by the Safe Drinking Water Act of 1974 and its amendments. So if you get your drinking water from a public water system, you are protected. Private water systems are not regulated. They don't have to meet the Safe Drinking Water Act rules. However, if you have a private water system, which means you might have your own well, you need to pay attention to the regulations and have your water tested regularly, basically just simply to ensure your safety. Okay, let's look at the definition of a public water system. Technically, a public water system is defined as this. They're drinking water systems that service 15 or more connections. I mean, if there's a water supply and it services 15 or more homes or apartments, it's considered a public water system. Or if the system regularly services 25 or more people daily for at least 60 days a year. That would cover resort areas that are only open in the winter or a small portion of the summer. So this means that if you live in a city or a town, you're on a public water system and you are covered by the Safe Drinking Water Act of 1974. If you live out in the country and you live in a rural subdivision, and in that rural subdivision are 20 homes, and those 20 homes get all of their water from a single water source, such as a well, that's considered a public water system because it's 15 or more service connections. Now, one acronym that's kind of confusing that you need to just be aware of is public water systems are abbreviated PWS. Sometimes they're called community water systems. If you get your water from a public water system or a community water system, that water system has to provide drinking water treatment to ensure that your drinking water is safe. So they have to ensure proper drinking water quality by monitoring. So that public water system has to take regular samples of the water that is providing its customers, test them for contaminants, and if contaminant levels are high, that public water system has to rectify that contaminant level or shut the water down or find another source of water. In addition, if there's a contamination found in the water supply, they have to notify the public of the contamination problem and what to do. The 1996 provision said that each public water system had to issue an annual report to their consumers. And living at home, every once a year, you get a report on what your drinking water supply was, the quality of your drinking water supply, the problems with it, the positives about it. So the public water system has to do all that. I like to call them public water systems. Some people call them community water systems. Basically, they're the same thing. So PWS and CWS are sometimes interchangeably used. But technically, all community water systems and public water systems, but technically, all community water systems are public water systems. On the other hand, some public water systems are not community water systems. For instance, a school that has its own water system in a rural area doesn't serve a community, but it has to meet the Safe Drinking Water Act rules. So expect to see both terms as you read about drinking water. And just remember, 98% of the time, public water systems and community water systems are the same thing. It's just that odd time where you have a school that has its own drinking water supply where it only has one service connection. It's a community water system, but not a public water system. Living in communities, we see all the time. Our drinking water is processed by our public community, and it's usually stored within the town. A lot of us live in towns where water is stored in towers that are high above the ground. This is an example in this diagram. The water is stored above the town, above the surface, so it can flow to homes via gravity. It provides water pressure for firefighting and things like that. Even if you live in a big city, such as in New York City, the water distribution system in most towns is underground. There's underground pipes that bring your safe drinking water from public water supply systems into your homes. So it's a pretty huge and pretty complicated network. So remember, if you get your drinking water from a community water system or a public water system, your drinking water is safe based on the rules of the Safe Drinking Water Act. %82 of Americans get their water from a public water supply system. So 82% of Americans are assured that their drinking water is safe. The other 18% get their water from a private water supply, or private water system, which we'll talk about in a few moments. This 82% for the overall U.S. population is probably the same percentage in our 4 Pacific Northwestern states. The Pacific Northwestern states are rather urban states. About 82% of us live in what we would call urban areas. So be assured, if you live in a town, you go to your tap and you get a glass of water from it and you drink it, you know that that drinking water is safe. It's not going to harm you. Now, we'll talk about this a little bit later. Some people aren't satisfied with their drinking water, even though it is safe. Some people say, well, the color is off, it smells bad, there are some physical things with it that you don't like. The color is off. Your drinking water is safe, but those things like color and odor are aesthetic things that consumers may not like, but there has been no link of those aesthetic issues with adverse impacts on human health. So the user in the home can go out and buy a secondary market filter to correct odor, to correct color, to correct other things. But that consumers should be assured that their drinking water is safe. Okay, let's talk about private water supply systems. These are drinking water sources that service less than 15 connections. Most of the time they're private wells. 90% of these private water systems are private wells. 2 or 3% of people get water from ponds. 2 or 3% of people get water from rivers. 2 or 3% get water from reservoirs. But 90% of the private water systems are wells. Beware, if you get your drinking water from a private water system, there are no rules that regulate the safety of that water. It's called a user beware system. You've got your permit, you've drilled your well, you can use that water, but whether that water is safe or not to drink, that issue is, the onus is on you. You have to ensure that your drinking water is safe. So users are responsible for the safety of drinking water from private systems. And about 18% of Americans get their water this way. Here's a diagram of a typical system. Basically, we have a well. The water is pumped up from the well using electricity. We have a jet pump. We have a storage tank. From that storage tank, it goes through a pump, and the consumer may have different filters to make their water better, or if they found a contaminant in their water, they might add chlorine to get rid of a bacterial contaminant. But they go through a system of filters that it's a user beware system. And then the water goes into the home and is used. And finally, I'd like to say that if you get your water from a private water system, users should have their water tested on a regular basis for potential contaminants. Now, where do you go for guidance? Where your state, your local health district, university extension, and environmental protection agency have pamphlets that provide information on how to test and protect private well sources. Thank you for your attention. We'll be talking about drinking water in the next lecture also. That the EPA would have oversight. But eventually, as states got up to speed, primacy would pass from the EPA to specific states. And I can remember back in the mid-1990s, 46 of the 50 states had primacy, and today basically all states have primacy. They run their programs with the assistance from the EPA when they request it. But basically states are in charge, and this is what Congress intended. EPA oversight, they would train and bring states up to speed, and then they would pass the primacy to the state because things work better at the state level.